All right, welcome to Fundamentals of Mathematics. This is section 1.1, and we're going to start out with problem number 1, and they want us to use Gauss's problem to find the sums of this arithmetic sequences. So there's a formula that they give you that says if you're adding up numbers in sequence starting from 1, which is important, you have to start from 1, and the formula needs to be counting by 1. So 1, 2, 3, 4, 5, etc., all the way up to some number. Then you can use this formula. N times n plus 1, where n is the number of terms you have, divided by 2. This is your sum. Okay, n is the number of terms. I'm going to use this pound sign to represent the word number. Okay, so this works if your sequence starts with 1 and counts in order 1, 2, 3, 4, 5, etc. Okay, so for the first sequence, we do have that. For A, we have 1, 2, 3, 4, all the way up to 99. Okay, so first, n is 99 because we see we started at 1 and there's 99 terms. Okay, so for part A, n is 99, and then 99 plus 1, we're going to be multiplying by 100, and then you always divide by 2. It's by 2 every time. That's the way the formula is set up. You can go back and look at it. Okay, so I'm going to do the math here. We're going to multiply 99 times 100 and divide by 2. Okay, so I'll just do that with the on-screen calculator. And I will add a link to show you guys how to get this. If you don't have a graphing calculator or a calculator of some sort, you will want to have something like that because we'll use it quite a bit. These are some big numbers we'll be working with. Okay, so on screen I'm going to do 99 times 100, and then I'm going to divide by 2, and that gives me 4950. Okay, so in this blank I'm going to insert 4950. Okay, and I got my first part. Okay, now for part B. This time we have a sequence that starts with 1, but it doesn't count in order consecutively. It starts 1, 3, 5, and it skips. So now this formula no longer applies because we're skipping numbers. So now we got to do something else. It's going to take too much time to try to add these up. So there is another formula that you can use, okay, when things do not go in order. Okay. And just say that you have a sequence, so it might start with anything. I'm going to say A1 is the first term. I'm just indexing it, A1. And then we have another term, A2. And then we got dot, dot, dot. We keep adding these up, and we go to some AN term. So we're still able to count how many terms we have. Okay, so the new formula that you can use says the first term, which is A1, plus the last term, which is AN. Just add the first and last one up, times the number of terms you have, which is n. You still have that n there, and then you divide it by 2. So if you compare this one and this one, they're pretty much the same. Like if it starts with 1, you can use this formula as well. So remember, 99 was our number of terms, so that was n. That would still be a 99. The first plus the last, if we're looking at the first one, the first one was a 1 plus the last was 99. 1 plus 99 gives you 100, and divide by 2. So this formula will work every time. This one works specifically if they go in order. Okay, so let's work this one out now. So for part B, okay, we have to add first and last term. So B the first and last term we have are 1 and 97. So if I add those together, we get 98. Okay. And then we have to multiply by n. How many terms do we have? Well, I don't want to sit there and count all those terms. So I'm going to try to show you two ways to try to find out how many terms you have. One, I was just kind of tinkering and I found out it works, and then I was trying to find an easier way to do it. And so let's see. If you look at that pattern on B, it's 1, 3, 5, so on, all the way up to 97. Okay, this pattern is counting by 2. In the book, they showed you one that was counting by 2 and started with an even number, and all they did was divide it, and then it looked like it was counting by 1 to get that. So we can do that same method, okay? So what I'm going to do is imagine just adding 1 to every term in the sequence. Plus 1, plus 1, plus 1, plus 1. We're only doing this to help us find out how many terms there are, okay? So if I added plus 1, that would just shift this sequence so that the sequence now looks like this. Sorry, let me get some more space. Now the sequence would be like this. 2 plus 4 plus 6 plus ... all the way up to 98. This is what we want because it will help us to find the n. Okay, so now notice all of these numbers are divisible by 2, so that's what we want to do. If you divide by 2, and we really want to just focus on this last term. If you divide by 2 though, so think about dividing everything by 2. This will give you 1, this will give you 2, this will give you 3, etc. And if you divide this by 2, that gives you 49. So all we've done, or what I've done, sorry, is add 1 just to shift the sequence, and then divide by the difference that it was counting by so that I can see what n is. So n is 49. Now it'll take a little bit of practice to draw that up, but it's going to be better to figure out some system that's going to help you count how many terms you have in order to figure out n. So again, what did I do this? Okay, I saw that we were counting by 2, so I wanted to divide by 2. However, I couldn't divide these odd numbers by 2. So what I did is I added 1 to everything so that it was even, and then I divided by 2, and that showed me a sequence that's 1, 2, 3, kind of like what we need in the beginning, and my last number was 49. So it counts from 1 to 49, and we're good to go. Okay, so, and we still divide this by 2, okay, in the formula. Now, the other way that I did it, I don't know if it will help you, is I used the formula. I said n, the number that you have, is equal to the difference of the first and last number. So I did 97 minus 1, and I divide that by the difference. So this is counting by 2, so I would divide by 2. If the formula were counting by 3, I would divide by 3. So you divide it by the difference, and then you add 1. This is maybe more complicated, I don't know, but this will give me 96 divided by 2. Okay, so let's do 96 . See if that gives me the same thing. $96 divided by 2, and then you add the 1, and you still get 49. So this is just another way that I was working on this. So let me write it down in a formula sense. I'll write it down on the next problem. Let's go ahead and solve this. So we have 98 times 49 and then we divide by 2. That gives us 2401. Okay, so let's clean this up. I'm going to erase this, and I'm going to clean this up and try to show you this a little bit better. So we got two more we're going to be doing like that. So here are the formulas. You have n times n plus 1. That's if you start with 1 and go in the sequence, you divide by 2. Or you have the first term plus the last term times the number of terms divided by 2. I was trying to show you how to find n, so I'll do it with the sequence. You guys will just have to let me know if you like this formula. N is equal to the last term, an, minus the first term, divided by d, which I'm going to call the difference, whatever your pattern is counting by. So if it's counting by 2s, 3s, 4s, whatever, you will put that number down here, and then you will add 1. Okay, so these are the things I've been using. However, we can manipulate that sequence. So look at this one on C. C, we have a sequence that starts with 8, and then 17, and then ... It doesn't matter. We go to 908. Okay, right here, from 8 to 17, we can see that this formula is counting by 9. That would be the difference that I would put here. So if I wanted to figure out how many terms this sequence has, what I would do is take 908 and subtract 8. So I'm going to do this formula right here. 908 and subtract 8. We're going to divide by 9. That's the difference, because each term is counting by 9 to get to the next one. And then you have to add 1. Okay, this is going to allow us to plug into this formula here at the top. Okay, so this is just allowing us to find n. Okay, so I'm going to pull up my calculator. We're going to do 908 minus 8. It gives me 900. Divide by 9. Gives me 100. Add the 1. Plus 1. Plus 1 equals 101. Okay, so we have 101 terms. 101. So if I want to figure out what this sum equals, it would be the first plus the last. So 8 plus 908. We've counted how many terms? There's 101. And divide that by 2. Okay. So I'll just type it in just like that. So in parentheses, I'm going to do 8 plus 908. And then close it. And then times 101. And then divide that by 2. Okay. So I get 46,258. Okay, so made an error somewhere. Let me look at this again. Look at the calculator, make sure I didn't type something in incorrectly. It's not the calculator. Okay, 8 plus 908. Looks good, 101 terms. Okay, so let me just verify it with the other method that I would use. So notice this pattern is counting by 9s. However, we don't start with a number that's divisible by 9. So I want to make this something that is divisible by 9. So if I was to take this and add 1, 8 plus 17 plus ... 908. Okay. If I added 1, kind of like I did in the other step, the other problem, this would become 9. This would become 18. And dot, 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 this would be 909. Now we've shifted this pattern so that everything is divisible by 9. So now if you divide by 9, or just kind of imagine dividing by 9, you will get a new sequence. And 9 divided by 9 is 1. 18 divided by 9 is 2. So if you just shift your sequence so that it starts with a number that is divisible by what it is counting by, what you're adding each time to get to the next term, you will be able to see how many terms you have. So 909 divided by 9 still gives me 101. So we have 101 terms. I'm not sure if I just typed it in incorrectly. 4, 6, oh yeah, I typed in 285, and it's 258. So that's my mistake. So you got these two methods. I just kind of wanted to show you those over and over again. You can find out how many terms you have by shifting your sequence, dividing by what you're counting by, or you can kind of use this little n equals formula. Okay, I just typed it in wrong, dyslexia. So this is going to be 258. I think I typed 285. Yeah, 258, I typed 285. Okay, so let's do this one more time with D. So I'm going to erase this part. Okay, so this formula is just going backwards, but it's the same thing. I'm going to write the smaller number first. 6 plus dot, dot, dot. Now, if you look at 685 and go backwards to the 678, because this is what we have. We have 685, and in front of that, we have 678. And then we got some more terms, okay? All we need is 2 terms side by side. From 78 to 85, 78 to 85, we're adding 7. There's a difference of 7, okay? I don't start with 7. So I've already just to add 1 to everything, plus 1, plus 1. My first term would be 7, and this would be 686. Okay, I'm just adding 1 to shift my sequence so that now if I divide by 7, this will start with 1. And if I divide by 7, 686 divided by 7, that should give me a count for the number of terms that we have. So we're going to do, 686. 686 divided by 7. So that tells me we got 98 terms. So I know we have 98 terms. That is my n. Okay. And then to figure out this sequence, I'm going to do first and last, add those together, times n divided by 2. So I'm going to do 6 plus 685 times 98 divided by 2. Okay. And that'll give me my last term. And I'm sorry that this video has taken a lot of work, but I'm hoping that I'm explaining this well enough for you to understand it and keep up with it. But it could be tedious. So just take your time and then it'll work out. Times 98. So 6 plus 685 times 98 divided by 2. And that gives us 33859. 33859.